we want the area under the curve y equal x squared on the interval from 0 to 2, we can begin by dividing the region into 4 rectangles. Our entire interval's from 0 to 2, so its width is 2 minus 0, which is 2, and we're dividing it into 4 rectangles. Each rectangle has a width of 1/2. We call its width delta x. The height of the rectangle is determined by the right-hand endpoint of each subinterval. This will give us a rectangle that's circumscribed about the curve. The area of the first rectangle is 1/2, which is the base, multiplied by f of 1/2, which is the y-coordinate of the right-hand endpoint of the interval. The second rectangle, its width is 1/2. The height is f of 2/2, or 1. The third rectangle, its width is 1/2. Height is f of 3/2. And the fourth rectangle is 1/2 times f of 4/2. We can see that each of these has an area, a width of 1/2. The height of the rectangle follows a pattern. The first rectangle, it's f of 1/2. Second, it's f of 2/2. Third rectangle, it's f of 3/2. And the fourth rectangle is f of 4/2. We can use a summation formula to represent the height of each rectangle. It would be the summation from I equal 1 to 4 to represent the 4 rectangles. The height of each rectangle is going to be f of 0, which is the left-hand beginning point of our interval, plus a multiple of 1/2. 1 times 1/2, 2 times 1/2, 3 times 1/2, 4 times 1/2. So it would be I multiplied by 1/2. Each width is uniform, and in this case is 1/2. To simplify this formula, we have the summation I equal 1 to 4, f of I times 1/2, multiplied by each width, which is 1/2. By substituting this into our calculator, we use F3, then the summation formula. We would do the summation, parenthesis, to begin the summation formula, we're going to put I times 1/2 into our function, which is that squared, comma, identify what the variable that you're substituting in for, comma, your beginning point, which we're starting at 1, comma, the end point is 4, end parenthesis to end that summation. We're taking the summation from 1 to 4 of this function, which is squared. And then each of those is going to be multiplied by 1/2. When we put this into our calculator, we get an area of about 15 fourths. 3 3/4. We can see that that area is a little large because we have all of this part that's outside of the curve. Now, how we can do a better approximation of the area beneath the curve is by finding more rectangles. So now let's look at the same curve on the same interval from 0 to 2, but this time we're going to use 100 rectangles. So now the width of each rectangle is from 0 to 2. To take away 0, we're going to divide it into 100 subintervals. Each width is no longer 1/2, it's now 1/50th. So we're going to have 100 rectangles divided in that area. Now the smaller that the intervals are, then the more accurate our actual area is going to be. If I could draw 100 rectangles in there, I would. Now what we would do is change our summation formula. Instead of 4 rectangles, we're now going to have 100 rectangles. The width is going to be 1/50th. So now each height is going to be f of 0 plus a multiple of 1/50th. multiplied by each base, which is 1/50th. To put that in our summation formula, it would be the summation from I equal 1 to 100 of 1/50th times I, f of 1/50th times I, and the width is going to be 1/50th. To put that into our calculator, it's going to be the summation. So you would go F3, summation formula, put a parenthesis, that's going to begin the summation, then put a parenthesis to put this into your function. It's going to be I times 1/50th squared, since our function is something squared, comma, identify what your variable is, comma, identify the beginning value, comma, and then your end value. We're going to do this 100 times. And the width of each rectangle is 1/50th. When we put this in our calculator, we're going to get a value of about 2.7068. This area is a better approximation of the actual area beneath the curve because of the fact that we're using more rectangles. Now on try these, number 1, we have the function x to the 6th power minus x squared on the interval from 0 to 1. Our interval's from 0 to 1, so it has a width of 1, and we're going to divide it into 4 subintervals. So delta x is going to equal our right-hand endpoint 1 minus our left-hand endpoint 0, which is a width of 1, and divided into 4 subintervals. The width of each rectangle is going to be a 1/4. Now to find the area of each rectangle, the width is going to be a 1/4 times f of, and we're going to use the right-hand endpoint of each interval. So we're going to start at 0, and we're going to add a multiple of a 1/4. So 1 times 1/4, then 2 times 1/4, then 3 times 1/4, then 4 times 1/4. So we can write this as a summation. A summation from I equal 1 to 4. The width of each rectangle is a 1/4. The height of each rectangle is determined by f of that value. So it'd be the summation from I equal 1 to 4, f of I times a 1/4 times a 1/4 for the width of each rectangle. To substitute this into our calculator, or to enter this into our calculator, we go to F3, take the summation formula. Then our summation formula is going to be parenthesis. This is going to be entered into our function, which is x to the 6th minus x squared. So it's going to be I times 1/4 to the 6th minus I times 1/4 to the 2nd, comma, I is our variable, comma, we're going to start at 1, comma, to 4, end the parenthesis, and then we're going to multiply that by the width of each rectangle, which is 1/4. So the end parenthesis here is the end of that summation formula. This is a constant, so it can be factored out of the summation. When we enter that into our calculator, we'll get our area is approximately 2.12803. Part B of that, we're now going to change from 4 rectangles to 100 rectangles. Since the width is from 1 to 0 again, but we're changing into 100 rectangles, each rectangle has a width of 100. Our summation will be from 1 to 100. The width, instead of 1/4, is 100. It'd be f, our beginning point 0, plus some multiple of the width, which is 100. Putting that into our summation formula, simplifying, it's summation from I equal 1 to 100, f of a multiple of 100th, times each width, which is 100. So we have the summation, F3, summation formula, I times 1/100th to the 6th power minus I times 1/100th squared. So that's the value of the function, which is changing in terms of I. Put a comma, I equal, not I equal, from 1 to 4 multiplied by this would be 100, multiplied by the width of each rectangle, which is 100. By using 100 rectangles, we're going to get a better approximation of the area beneath the curve, which would be 2.3799, a more accurate representation of it. Now, in part 2 of Try These, there's now going to be a little change because our interval does not start at 0. It now starts at 2. So we're going to take the parabola x minus 2 squared on the interval from 2 to 4, which is a parabola that has a horizontal translation of 2 units. When x is 2, y is 0. When x is 4, y is 4. Dividing this interval into 4 subintervals, delta x is going to be 4 take away 2, the right-hand endpoint minus the left-hand endpoint, divided into 4 subintervals, which would be a half. So each rectangle has a width of a half. The first value is going to be 2 plus a half. The second is going to be 2 plus 2 halves. The third is going to be 2 plus 3 halves. And the fourth is going to be 2 plus 4 halves. So each rectangle has a width of a half. The height is going to be determined by the right-hand endpoint of each subinterval. So our area can be approximated by a half. The first rectangle is going to be f of 2 plus 1 half. The second rectangle is going to have a width of a half. Height is f of 2 plus 2 halves. The third rectangle is going to be a half multiplied by f of 2 plus 3 halves. And the fourth rectangle is going to be a half, f of 2 plus 4 halves. Since our interval starts at 2, we have to start at 2 and then add a multiple of a half for each height. Our area can be approximated using the summation formula from I equal 1 to 4. Each height is going to be f of 2, which is our initial beginning value, times a multiple of a half, I times a half. Each width is 1/2, which is delta x. By substituting this into our function, or into our calculator, and using the summation form of our calculator, it would be the summation. We're going to enter this into our function, which is the quantity, x minus 2 squared. So it'd be 2 plus I times a half, that substitutes in for x, minus 2, quantity squared. Our variables I, we're going to start at the endpoint 1, end at 4. So this is our summation from 1 to 4, and each width is 1/2, which is delta x. When we substitute this into our calculator, we're going to get an area of 15/4, or 3.75. So the area beneath this curve is less than 3.75 because you can see the rectangles are actually circumscribed